Good. Keep asking those questions and clarify it before you. Yeah, sure, which one? Okay, number 12. If you see here.
Like I know this, it's like if you already know what the square root is.
Yeah, so tell me, so I'm gonna break it up into each part, okay? Tell me, what did you get for this part?
8.
Okay. Is this a perfect square?
No,
How are you gonna break it down?
M to the second.
Okay, square root.
And then M.
Okay,
And the
and,
next one would be N to the second. And I don't know if it's in there.
okay, what's a square root of m squared?
There's, oh wait, no, just 1.
What, m to the what squared is m squared? Yeah, m to the 1, m to the first. So that is the square root of m squared. M to the
M.
first. So that becomes m, so this is 8 m root m. And here,
Oh, M squared.
what's the square root of m squared?
N.
N? What do we do with this?
Just
Stays the same. What do I bring out in front?
the N
And
to the front.
with this.
Yeah. And then
So?
the N. Oh, okay.
And the things inside stay together.
Cause like, alright, I just keep getting confused at like the rules of exponents.
Yeah. Will this be on the test? Yeah. Yeah, that's what we're spending a good amount of time figuring it out. All right, you guys, go ahead and take out your notes. This is, last class we started simplifying radicals. This class we're going to continue, except part 2. Part 2, and then that's when you're going to be able to do the back side of that worksheet. So you guys will take out your notes from last class. Simplifying radicals, you can either just continue it or label it in part 2, please.
D-ball activity?
That's what I said, you gotta have comfy shoes.
Is that about my basketball games?
I know, someone told me that. Yeah, that'll be exciting. Okay, guys,
Where?
simplifying radicals, part 2. And at the end of our lesson today, we are going to do a little basketball activity that's going to help us reinforce some of what we've been learning. And so that's why I warned you that I hope you guys brought good shoes so that you can stretch your stuff when we get to that part. All right, guys, simplifying radicals. Let's just take a look really quickly. I think in class, the only one we got a chance to do is square root of 20 y to the 4th. I'd like you to just quickly go ahead and simplify these other 4, just as a quick review before we move on to additional stuff. All right, go ahead. And when you're finished, please check your answers with the neighbor. Be ready to share out. I will be pulling from the cards, so you will be held accountable. How did it go? Any questions? Still looking up? Okay, my recommendation is just like I showed you in the warm-up, in the homework tutorial, break it up to numbers separately and each type of variable separately. So you're not getting confused. whole point of this is if you can't take the square root, take the square root. That's why you broke it up. Okay? That's why I always tell you to write it first, to write the perfect square first, because then it's already in front. All done? There we go. You got it? Great. Right. The idea is if you, to find the biggest perfect square with the variable, you just subtract 1.
Oh.
Because that's the biggest even number, is if you just subtract 1. Yeah, so y to the 6th and y.
Oh.
And then break up square root of y to the 6th. Always just subtract 1. Guys, take a look at Nicole and Jessica. They're checking their answers with each other. That's what you should be doing. Be confident and ready to share out in front of the class. Make sure you have no perfect squares left inside the radical sign. Okay. Jane, can you check with Fiona because she's done?
Not right, so
Okay. What's the square root of y?
Oh, he's like,
No, you're not breaking it up like that, but back up here. We did this. We broke it up to this and this. Now, we took the square root of that.
Oh, why is it? Hello. Oh, so why is the third one?
Huh?
Oh, see, it's just divided by 2.
Right. So exponents work differently than the coefficients. You're not doing the same thing. All right, guys, here we go. Let's see what you guys came up with. Starting with the first one. Let's see if my smarty is on. Square root of x squared, Dylan. X. Any questions on this first one? Raise your hand if you got it right. Great. Next one. Square root of y to the 7, Jess.
I got,
How do you break it up first?
you have to get the biggest even number, which is y6 to the 6th power and y.
And so now, my final answer?
Y to the 3rd power and y.
Square root of y. Very nice. Raise your hand if you got it right. Excellent. Moving on. Next one. Did you guys all do this one? Or did you skip it because I said we did it last time?
oh,
I did.
You did it?
We did it.
You did it? Well, Aiden, your name is called. Did you do that one yet? No? Okay, that's okay. Let's just move on then to this one because we did this one in class last time. Yeah, I'll just put it in case you didn't. You want to check your answer. So you can break up square root of 20. Oh, no. Oh, no. This thing likes to jump.
smartphones. Do you like smartphones? Do you like
Go back.
them down wherever you?
There we go. 20 we can break up into what factors?
4 and 5.
4 and 5. And we have square root of y to the 4th. Square root of 4 is? 2. Root 5. Square root of y to the 4th is? Y squared. So bring out the stuff in front that's already outside. That should be your answer. Okay, raise your hand if you got that one right. Great. Next one, a little more challenging. Yole.
You spread out like 9 times 3
Okay.
times y10. Y10 you simplify y.
Okay, how about square root of, here, let me just finish writing those out individually. Okay, so let's do one by one. This, what do we get?
That you get 3.
3, root of 3, this,
That you get x.
this,
Y to the 5.
and this.
You remove the 1.
And in front, we'll put all the stuff that's outside. So 3x, y to the 5th, root 3w. Raise your hand if you got it right. All right, nice job. You guys are doing some really challenging problems. So nice job on that. And finally, Anthony, did you get a chance to finish this last one?
I'm doing it.
You're doing it? Okay.
Wait.
You got it? Okay, tell us what you got.
W to the 8th,
Okay, so you explain that to w to the 8th, square root,
and then W,
uh-huh,
and P to the 6th,
good, and,
and P.
great. How do we split that?
You put the even ones, or you divide them by 2 and put them outside, so
Great.
W, Y to the 4th. I mean,
Okay,
W
and,
to the 4th, and P to the
And inside? Excellent. Raise your hand if you got that one right. Very nice. If you got them all right, please give the person next to you a big high five. Did you get it right? Yeah, all right. Awesome. Okay, guys, we are gonna move on now to the new stuff. And now it's the same exact thing, but
More complicated.
we haven't been using it.
Let's look at this.
So that before it said, you said that.
No, I just erased the ink. Hold on.
Okay.
We're doing the exact same thing, except in a fraction. Amazing. We love fractions. We love it. We love it. Guys, the quotient property. What was the other property we learned? Product property. Now we're learning the quotient property. And if you remember, the word quotient means division. Okay, let's take a look. Basically, what the quotient property says is if you have a fraction inside of a radical sign, something you're allowed to do is break it up and take the square root of the numerator and the square root of the denominator separately and then put it back together. Okay? No, it's not that hard. Okay?
Oh,
So
that's like the.
if you take a look at this and you're like, oh my gosh, Miss, 9/4, I have no idea what the square root of that number is. Well, the quotient property comes to your rescue because you can split it up into this and then take the square root of each one separately. The reverse is also true. So take a look if I had an example like this. If I had an example like this, and I wanted to do this over this. And you look at that and you're like, square root of 2, can't take that. Square root of 50, you're like, ooh, I can simplify that. But something that you're allowed to do with the quotient property, and please write this down, is the same way we went from here to here, you can go from here to here. So instead of two separate radical signs, you can put them together as one big fraction. What's the benefit of me putting it together like that?
You don't have to work out two separate.
Okay, well what else in this particular
Can you
problem?
repeat it? When you divide 50 by 2 times 25, you cancel out 2 and 2.
Okay, well now we can simplify the fraction. When I put the fraction together like that, look, 2 over 50 cannot reduce 1 over 25. And now, 1 over 25, now I can split it back up, square root of 1 over the square root of 25. What's the square root of 1? 1. What's the square root of 25? 5. So now I'm able to get an answer. This is called the quotient property. It's very much like the product property, except now with a fraction, with division. Okay? Any questions?
Where did the 2 go in the 25?
Here, because we reduced the fraction. So that way, if you wanted to, this particular problem, it's not always going to work like this, but this particular problem, if you looked at this and you're like, okay, I can't touch the 2, but on the bottom, I can split it up to this. So maybe some of you saw this. Maybe Violetta, this is what maybe you were suggesting earlier. Here, the square root of 25, we know that just becomes 5 on the bottom. And then root 2 over root 2 cancel to a 1. So you can still get the same way that way, and maybe that's what you're referring to. However, sometimes it's not going to cancel like that, and so know that you're allowed to go from separate to together, back to separate to get your answer. Okay? So let's go ahead and try one now. No, that wasn't supposed to Let me clear this ink so you can see what you're doing. That's what I wanted. Okay, take a look at this fraction. Inside the radical sign, you might notice that, as a fraction it looks scary. But using the quotient property, split it up, take the square root, check your answer with the neighbor. Go ahead and try that now. What's that? This is not square root of 4 or square root of 9. Once it comes out of the square root, it's out of the square root. That's what I was saying. Don't just keep reducing. Reducing fractions is different than the square root. Okay guys, I want to show you first of all, let's see what we got for the answer here. Nicole, what did you do?
I separated it into root 16 over root 81,
Great.
and then you get 4 over.
Okay. Now, at this point, look to see if you can reduce this fraction. Is there anything that you can do to reduce this fraction?
No.
Yeah?
You could find the square root of 9.
Why would we want to take the square root of 9?
Oh wait, no, never mind.
Okay, this is what I want you to be careful of. And Maria just asked this question, and it was a great question. That's why I wanted to talk to you about it. Guys, once it's out of the square root, it's out of the square root. Stop taking the square root of it. When we try to, Maria, go ahead and put that on my desk. You guys know cell phones aren't allowed, and you know you're gonna get caught, so just don't even bother. All right, when you're taking the square root of something, it's not the same thing as reducing a fraction. Okay, it's not the same thing. So we're not going to try to keep taking the square root of it until you can't anymore. We just look, if you can reduce the fraction, for example,
The smartboard just loves you.
it loves, actually it's worse with Mr. Pi, so I get pretty lucky with it compared to him. If I had this, could I reduce the fraction? What do I get?
2 over 4.
1 over 2, 2 over 4, and then 1 over 2. What did we do here versus those of you who try to make this 2/3? What's the difference between those two things? Aiden?
With the 4 over 8, you're just making this fraction smaller.
Okay.
But with the 4 over 9, you can't make it simple because there's no common denominator.
Right. This is reducing the same fraction, it's the same value. If you try to take the square root, you're doing something wrong. You're taking the square root of something that is not asking you to take the square root. Okay? Alright, so be careful of that because those are very common mistakes. Alright, so now, this is, finally I wanted you to see this picture. Disaster's about to happen. And now, show me that disaster is not gonna happen, that you know how to do this. We're gonna try a few of these problems out and see how well we understand them.
Instant answer. Just so good.
Okay, I'm gonna give you a few seconds to do each one, and then we're gonna move on. So, check your answer.
Improper.
Yeah, improper fractions are fine. Check your answer with the neighbor.
We got it right.
7 over 4.
And now, try this one.
What do you get
Go ahead, try this one. And when you're done, check your answer with the neighbor.
What you get?
And now, try this one. Okay, this one. What should you do first?
Fine. I will split it up.
Should you split it?
Yeah.
Is it gonna help you if you split it?
Not
Yes.
No.
No, I mean if you.
What's better to do?
55.
Reduce the fraction first, guys. If you can reduce the fraction, reduce it. Simple, come on.
4 and 1.
Reduce it and then take the square root.
What do you get?
4 and 1. What do you get?
No, one's in the square root. Square root of 5 is very different than 5. If you check your calculator and try the square root of 5, it's nothing close to a number. Okay,
Kachai or no kachai?
did you guys get that?
Got it.
What's 20 over 5?
Or-
Okay, so this is gonna be square root of 4. And now what's the square root of 4? 2. Did you all get 2?
Yeah.
Okay, try this next one. Okay, check out what's happening. Check out what's happening.
No.
Go ahead, try it out. Check your answer with the neighbor.
Do you have to like split it up?
And 20.
Oh, if you can reduce it before you split it up, reduce it. Those exponent rules are not gonna go away. You gotta master them sooner or later. Okay, and then check your answer with the neighbor. Okay, guys, I'm gonna put 3 more problems up here, and I would like you to work out these so that you have all 7 problems completed, at which time I will ask some of you to come put them up on the board. So please finish those 7 problems up, check your answers, feel confident. I'm gonna give you guys about 3 to 4 minutes, okay? Go ahead. Trying to get everything out of the square root sign possible. So never leave anything in the square root sign that can come out. Sometimes both of those can come out, so don't leave them in the square root sign. The 3 over 1 can be simplified to 1.
I mean, 24, sorry, 24.
Okay, and what happens to the x? What are your rules? There should be. So which one goes away? And one spot. Now it's just now it's just like the problem. Break up 24. Guys, when you're done checking your answers with the neighbor, raise your hand. I want to see who's completely finished. Great, you guys are all completely done. You agreed on everything? All 3 of you? Great. Stuck on 3. See if there's someone next to you stuck and see if you can help them out.
Simplify this up. Just put the 1 up there, so you get 1/2. Wait.
Now you need to simplify that. How do you, this was like last night's homework.
Oh, okay.
You split up to square root of 24 and square root of, okay?
We'll do this, please.
Well, I can use square root of 2. Okay guys, if I call your name, please come up to the board and pick one of the problems to do. Please look at the way I've coded the numbers, so we're skipping this one because we've already done it as a class. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Are there any questions? Jesse Brown, come on up. Camila Cadena, come on up. Sarah, Luis, Maria, and Violet, come on up. You guys, there are markers here. Also. Write the original problem up, please, and then you're correct. I mean, you're simplified.
Yeah.
Yeah.
How did we go? Did you guys agree on everything? Maria, can you show us the process? So for example, here, first you Technically, the answer's still the same, but technically you should split this up, you two said, you should be splitting this up to square root of 49 over square root of 16 separately, then you get your final.
Yeah, I know, but I didn't.
If you borrowed a marker from the bundle, please put it back in the bundle. Thank you. Jesse, did you do this one? You do this one? Okay. Can you show us how you got, are you putting these together and reducing them? Then you need to show us that you put them together. So you can show us this and then put it together before you reduce it and then show us this. And then bring it up.
Homework or?
I gave him the wrong answer, and then I was like, wait, I made a mistake.
Okay, good. Guys, please take a look at the board. Thank you for the people who really took the time to show the steps. Please take a look and see which ones do you have doubts on, which ones do you want to talk about and review, okay? So take a look at each one separately. Notice here on numbers 4, 5, and 6, the idea is if they're separate and you see that, ooh, if I put them together as a fraction, I can reduce it, then do it. So we put it together as a fraction, we reduce it, and then we take the square root. We put it together as a fraction, I like the way, who did this? Cami, I like the way she did also to see a different approach. She said, okay, instead of combining it as a fraction and then taking the square root, look what she did. She's like, oh, I'm just gonna reduce square root of 28 to that, and then anything that's exactly the same over itself, even if it's in a square root. So square root of 7 over square root of 7 is a form of 1. So that cancels to just a 1. And then square root of 4 on the bottom becomes 2. So that's another way of doing the same thing. Okay, so this is one way of looking at it, another way. And Luis's is more like Jesse's over there, where he put it together as a fraction, reduced it, and then took the square root of each one separately. Anybody have questions about number 3? The other did a great job showing her work here. Okay, she reduced the fraction using rules of exponents, and then took the square root. We should need to go all of them, right? I'm really impressed, you guys. All right, the last part of our notes is something called rationalizing the denominator, okay? Rationalizing the denominator, and this is something that I want you to know the terminology because you're going to be using this phrase, rationalizing the denominator. Before we talk about what does it mean to rationalize the denominator, I want to review really fast what does it mean to completely simplify your radical expression. So there are 3 requirements to know that you're done with your problem. And here are the 3 requirements. You already know what they are. There can be no perfect squares in the radicand. If any number inside or any variable inside the square root sign has a perfect square factor, it's not finished. You have to keep going. No perfect squares in the radicand. There can also be no fractions in the radicand. When you're all finished, there should be no fractions left in the square root sign. Now you might be looking back at the problems we just did. Did any of our answers end up with fractions inside of the square root sign? Look at the answers. No. We simplified them all the way until there were no more fractions inside of the radicand. And the third requirement, to make sure it's simplified all the way, you're not allowed to have any radicals left in the denominator. So if you look back at our answers, we have no radicals in the denominator. And this is what you have been doing, but I wanted to show you what exactly it